Hi guys! In this lesson, I will show you the basic working principle of parallel circuits in detail. At the end of this video, you will learn how to calculate current and voltage in parallel circuits. Here, I will show the parallel connection types using resistors in a direct current circuit. Components in an electrical circuit can be in series, parallel, or mixed connections. In this tutorial, I will demonstrate parallel connection. When we connect the two pins of the components, we have a parallel connection. In this connection, all resistors have the same voltage. Therefore, the current flowing through them is inversely proportional to the resistance values. A small current flows through a large resistor, and a large current flows through a small resistor. Since the same current flows from all lamps in series-connected lamps, when one of them explodes, the other does not light. Because the place where the exploding lamp is will be an open circuit, no current will flow from the other. Here, the solution is parallel connection. But it is not so with parallel connected lamps. Since all lamps have the same voltage, even if one of them explodes, the other continues to burn. Here, we have given an example of a lamp as a load. It can be any circuit element instead of the lamp. In LED strips, all LEDs are connected in parallel. Even if one of them breaks down, the others continue to shine, or it is possible to use the sections separately when we cut from a point of a certain length. It doesn't make much sense to connect the LEDs in series. Because each LED holds a certain voltage on it, it will cause a voltage drop. Therefore, it is ideal to light up multiple LEDs by connecting them in parallel. However, before doing this, we need to make sure that all the LEDs have the same power rating. In parallel circuits, we find the total resistance by adding the inverses of all resistances. If we name the resistors here as R1, R2, and R3, the total resistance will be 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. Total resistance is shown as RT. We can find the total resistance by adding the opposites of all the parallel resistances. For instance, suppose there is a single resistor circuit connected to the power supply. Let its value be 5 ohms. What is the total resistance of this circuit? It's very easy to find. Since there is only one resistor, the total resistance will also be 5 ohms. If we add a second 5 ohm resistor R2 in parallel with this resistor, what will be the total resistance? In this case, the total resistance will be 2.5 ohms, which is the sum of the two terrestrials. If the two resistor values are the same, the result will be half the value in parallel connection. Well, let's add another 10 ohm resistor R3. The inverse of the total resistance will be 1 over R1 plus 1 over R2 plus 1 over R3. From 1 over 5 ohms plus 1 over 5 ohms plus 1 over 10 ohms, the inverse of the total resistance will be equal to 5 over 10. When you do the inner and outer product, the total resistance will be 2 ohms. In parallel connection, the total resistance is less than the smallest resistance. For example, let's say we connect two resistors of 1 ohm and 100 ohms in parallel. The total resistance will be less than 1 ohm. So, how do we find the current flowing through the resistors? Now, let's look at it. We have said that in parallel connected resistors, there is the same voltage on all resistors. Since the source voltage is 3 volts here, the voltage across the two resistors will also be 3 volts. I1 current becomes 0.6 amps from 3 volts divided by 5 ohms. I2 current becomes 0.3 amps from 3 volts divided by 10 ohms. If we want to find the main branch current, that is, the total current, we need to add the currents I1 and I2. That would be 0.9 amps. We can see that the current flowing through the resistors is inversely proportional to the resistor values. A small current flows through a large resistor, and a large current flows through a small resistor. If we want to find the total resistance, we can find it by dividing the source voltage by the total current. Total resistance will be 3.33 ohms from 3 volts divided by 0.9 amps. Or we can get the same result from the formula for the sum of the inverses of the resistances. When we connect the power supplies in parallel, we still get the same voltage. For example, when we connect two 9-volt batteries in parallel, we get 9 volts again. If you remember, we were getting the sum in serial connection. Even with 3 sources, it will still be 9 volts. So, what are the advantages of paralleling? We get the same voltage, but we can use it for a longer time. For example, if we can use a clock when we connect a single battery to a load, we can energize the same load for 3 hours when we connect 3 batteries in parallel. In series connection, we can obtain higher voltage and provide higher current. In parallel connection, we must be careful that the power sources have the same power values. They should all have the same feature. This is the working principle of parallel connected circuits. I hope this lesson was helpful and you liked it. Hope to see you in the next lesson. Goodbye!